This is video 17.3. We will be solving a problem with unknown charges. The question: charges 1 and 2 are arranged as shown in the figure below. Now suppose the electric field at point A is precisely 0. We'd like to know what is the ratio of charge 1 to charge 2. Here Z is an unspecified unit of length. Step 1 will be to write down the field due to charge 1. Here I'm specifying that plus x direction is to the right, as usual. We need to keep this in mind because although charge 1 and charge 2 are both along the x-axis, making this a one-dimensional problem, the electric field can still have a positive or a negative value depending on the charge and the location with respect to the charge. So here, R1, which is the vector that points from charge 1 to the point A, is plus z in the x direction. Here, instead of using vector notation, I use the I hat, j hat, k hat notation to keep track of the different components of a vector. Now the formula for the electric field is the same one we used in the previous video. And if we plug in the value for R1, we obtain this result, which can be simplified further to k times q1 over z squared I hat, where once again the I hat is a reminder that it's pointing in the x direction at point A. Now step 2 will be to write down the field due to charge 2. We follow the same procedure, except in this case the vector that points from charge 2 to point A is in the negative x direction, and the distance is 3z, so it's negative 3z I hat at point A. The same formula for E2. Here we've plugged in our values, and we obtain a result of minus k times q2 over nz squared I hat. Now the problem said that the electric field at point A is 0, which means that the sum of E1 and E2 are 0. We'll take this to be true and then use this to solve for the ratio of Q1 to Q2. So here I've just written it down, and using our expressions from above, this implies the following relationship, which further implies this relationship by simply moving the second term to the right-hand side. Now we can cancel out the k's on both sides, and we can also cancel out the factors of z squared that appear on both sides. Now if we divide both sides by q2, we have the following ratio. The ratio of charge q1 to q2 is equal to 1 over 9. Notice that we expect this ratio to be less than 1 simply because charge q1 is closer to A than charge q2. So in order for q2, the field due to q2, to be equal to the field due to q1, it has to be a higher charge because it's a farther distance away. And in this case, the ratio of the distances is 1/3, but because electric field dies off as 1 over r squared, the ratio of the charges must be 1 over 9 in order for the electric field to be precisely 0 at point A. And this concludes video 17.3. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.